Welcome! In this project we are going to use the Arduino board and C++ programming to create a doorbell. I will show you an example here. So if I start the simulation and I click on the button, now I've made mine sound, it's a sort of evil doorbell from one of Bill Bailey's comedy routines. I think you can look on YouTube if you want to find it. You will have a bit of creativity in this project too, because you can create whatever melody you like for your doorbell. So I just wanted to show you what the project was like, and let's get started. For this project, we'll be using an online environment called Tinkercad. If you Google Tinkercad, it is the first result here. Now you should be able to sign up or sign in with your Google account. Once you've done that, if you click on Create and Circuit, because Tinkercad also lets you do other things which we won't be doing, you will go to this view here. Now, just a brief introduction, we have this workspace on the left, and on the right hand side we have all of these electronic devices. We will be primarily using the Arduino, which is a small microcontroller chip on a computer board that can be used to write computer programs that control electronic devices. You can also drag on other things that you might need for your project, such as lights, resistors, and switches, etc. And you can, by left-clicking, wire up different components and connect them into electric circuits. You can also write code for the chip on the Arduino by clicking on the code button here. We will be using the text rather than the blocks, and the code will be written in a language called C++, which is fantastic for running very, very fast on low-powered, inexpensive chips like the Arduino. Your project should auto-save without you having to do anything. And if you want to change the name for what your saved file is, you can do so up here. So in programming and engineering, it's very important to not try and do everything at once. You try and break larger problems down into smaller chunks to achieve. So I think what we will try and do is we'll try and get the speaker working first, then we'll try and get it playing a melody, and then we'll try and get it to be activated by a button. As you can see, these are two separate circuits here. And that's very common for electronic devices that have computer chips, is you have one circuit here sensing when the button's pushed, and then it will use the code to trigger the second circuit to complete the circuit for the speaker to play. The first thing you'll need to do is to go to Designs here on, well, presuming you've already logged in and you've joined the correct class. Click on Designs, click on Circuits, and make a new circuit here. I'm going to change the name up here to Doorbell, and let's get the equipment that we need. So in the search bar over here, we can search for Arduino, and we can get the Arduino. We are also going to need a breadboard. We are also going to need a speaker. It's called a piezo in this. I might be pronouncing that incorrectly. Now, when you're using the actual Arduino kits, you should make it on Tinkercad first, but after that you can make it on the real kits if you like. And just a few things. Number one, this is a passive speaker that we're using, not an active speaker, and we'll talk a bit more about that later. But in the kits, make sure you get the passive speaker. The second thing is that the speaker will sound much better in real life than it does on the simulation. It really doesn't sound great, but just bear with it. And the final thing that we will need is a push button, but we will just leave that down the bottom because we're not using it yet. So there's all the equipment, and let's get going. So what I'm going to do is we need to get the speaker here set up on the breadboard. You could put it anywhere on the breadboard, but I'm just going to put it here, so that, remember, it would be very easy to attach things to each one of the pins here, because any wire that we attach to any one of these 5 holes here, they're all attached, so that will connect to the positive and the negative very easily. Now, we don't want to pass 5 volts through this speaker all the time. We want to be able to control it with the programming. So we'll grab one of these. 0 and 1 I usually don't recommend because they do other things as well. So let's grab 2. I'm just clicking here to try and make a really nice, neat, and I might just adjust here. When things are neat, it's just so much easier to work out what's happening. And the second thing that we can do is we can attach the negative terminal here to the ground, like this. But I'm actually going to do this a little bit of a different way. On the breadboard, if I hover over the negative row here, or column, you'll see that this is all attached. And what this is designed for is you can actually attach ground to the end of here, and then this entire row becomes ground. And then anything that you need to attach to the ground, such as this, you can just attach to that row there. And so you're basically making this an entire ground row, which is quite convenient. Traditionally, the negative side of things is black, so I'm just going to make these black wires, and the ones that are, this is not really a positive wire all the time, which would be red, so what I might do is I might just leave it green, indicating it's sort of a computer controlled wire that may go on and off. Now I'm going to need to explain a little bit about how this works, and this is what you've got yourself in for with microcontroller programming. It's really about understanding some of the physics and the electronics beneath what's happening. So there are 2 types of speakers. If you look in the actual Arduino kit, you'll find there's an active and a passive speaker. The passive speaker you can see is on the left here. That's the one that we'll be using. And it has this sort of, in our Arduino kits, I think it has the green, the same as this on the bottom, whereas the active speaker seems to be sort of sealed in some way here. The active speaker also has a sticker on the top, which you should remove, otherwise the sound won't come out quite so well. But we're not going to be using the active speaker at all, so maybe leave the sticker on it so people don't get confused. We're going to be using the passive speaker. So what's the difference between an active and a passive speaker? Well, the way that both of these speakers make sound is by the electricity that's coming in actually creates a wave. So you'll know that sounds can be represented as waves like this, and what that means is that it's the change of pressure in the air that's coming towards you. And the speakers, how they create that wave is the electricity gets turned on and it's at full, then suddenly the electricity gets turned off, and for a little period of time there's no electricity, then the electricity gets turned back on again, so you get these pulses of electricity creating what we call a square wave. Now in an active speaker, you can just activate the power, and the speaker itself will create a tone by turning the electricity on and off in little pulses. Now we're talking hundreds of times a second here to create a tone. But active speakers will only make one tone, and it's the tone that or the note that they came manufactured as. A passive speaker is a bit harder because you actually have to turn on and off these little pulses of electricity hundreds of times a second through here to create the note. But the good thing about that is you can change the speed that you send these little pulses, and it will basically give you a different note. And there's an inbuilt function that you can use in the code. So let's look at that. Let's start looking at that. Go and click on the code icon here, and we'll delete the block code because we're going to be using the C++. and select text over here. I'm going to make my page a little bit bigger so we can see it easily. And I'm going to delete these comments because they're just getting in the way. So here we have the basic code. We have our setup function that runs once at the start of the program, and the loop that runs as often as it possibly can, which is why we have a 1/100th of a second delay there, just so it doesn't sort of run faster than it needs to and lag the web browser. So how do we actually, what function do we put in here to, maybe we'll just make it so that it will make a tone when the program is initially run. So I'm going to tab in there and I'm going to use a function called tone. And you might wonder how I know where to get that function from, and I'll show you. If you go to the reference, so if you type Arduino reference, there is a list of all of the functions that you can call on the Arduino, the specific Arduino ones, and you'll see here there is a function called tone, and it actually tells us how to do it. So it says generates a square wave, just like we talked about, of the specified frequency on a pin. So we have to give the pin number and then the frequency. So the frequency is how many times a second it goes from high to low, back up to high. So sort of one cycle of the wave, right? So how many of these per second? That's the frequency. So if it's 300 times a second, we call that hertz, 300 hertz. And if we want to play a specific musical note, we can look up what the frequency is of those notes. So if I type in note frequencies and go to one of these pages, we can see here that I think the middle of a piano, the C, middle C on a piano is, I think, the C4, the fourth C. So this is like the middle of a piano, C4, and it says here that the frequency, I'll just check the top of the column here, frequency, yep, so middle C, 260, well let's round up to 262 because we can only give an integer, a whole number, to this function. So 262 times a second, it'll have to oscillate on and off, right? So 262. So let's go back to our circuit design, and let's say we want, I think is it pin 2 we connected to? Yep, we want pin 2, and we want 200, what did I say? 262, okay. So 262. So we want tone on pin 2, 262. Okay. Now, you might remember we also have to, we also have to set the pin mode for pin 2 to be output. Output. There we go. And every line has to end with a semicolon. So what should happen, hopefully, when we press the start simulation, is you should start to get the speaker playing a C, which is a middle C, sort of a middling sort of note. And it should just keep playing it until we stop the simulation. Yep. And if we were to change this number to a higher number, let's say 400, hopefully we'll be able to hear that it is actually higher. Okay, like I said, that doesn't sound great, but it will actually sound better on the actual kit. Finally, we might then say delay for 1 second, which is 1,000 milliseconds, and I believe no tone on pin 2 stops the tone. So we start it 1 second and then stop the tone. Okay, and there we go. We've created some music on the Arduino. Okay, in this video we are going to actually create some music, or a little tune for our doorbell. And I'm going to keep mine simple like before, but you can make yours as complex or as interesting or happy or sad or whatever it is that you like. So the first thing I'm going to do is actually find a bit of an online piano. Hopefully we can find one at school that's not blocked and come up with a little tune. So here we are. I've searched for virtual piano, and I want one that actually has the keys. Well, I mean, you don't need one that has the notes written on the piano if you've done piano or music before, but it's a little bit easier for this case to show. Okay, so my guess is that this is actually C4, middle C, in the middle of the piano. This piano doesn't look like it actually is a full-size keyboard. It might be a lot shorter than that. But my one, I believe, was FCB. So you can just play around. It'd be a little bit easier if you use the white keys only, do it in the key of C, but that's up to you. Just come up with, you might have a simple doorbell like that, just two things. Or you might have some really complex melody, but mine was FB, oh no, FCB. I want it to sound a little bit like ominous, right? So I remember this one here, this is C4, so this is going to be F4, the fourth F on the keyboard. This is going to be B4, and it always changes up to the next number on the C, so this will actually be C5. So we want F4 on that list that we did before. We're going to want, for mine anyway, F4, so we're going to want 349, and then B4, 494, and C5. Now, instead of typing these numbers directly in, I really suggest we save these in some variables at the top of the program to make things a bit easier for ourselves. So I just paused the video there and created some variables. So in Python, we would just have to type F4 equals 349, but in the C programming language, we have to actually tell it what type of variable it's going to, or what type of data it's going to store. An integer is just a whole number. And in fact, this function, the tone function, only takes integers. In fact, it won't really make a functional difference for this, but to be totally correct, when we look at the documentation for tone 2, it takes an unsigned integer, which is slightly different, but I don't want to get too complex for this at the moment. So we create a new variable called F4, which can only, which is designed to store an integer, and we've stored 349, and I got those off the other list, and I rounded them to the nearest whole number, because we can only use whole numbers for this tone function. Okay, that's just going to make things a little bit easier here, because now instead of putting a number here, I can say play F4, and I can just put the note names in here. And if I want to play, say play F several times, I just use F4 instead of retyping 349, 349, 349. It's just a lot cleaner to code. So it's time for me to make my particular little tone, and at the moment I'm just playing it on setup. So I'm going to play F4 for 1,000 seconds, 1,000 milliseconds, 1 second. And then I'm going to play tone again on pin 2, because that's where our wire is. I'm going to play C5. And then we'll have a delay of another 1,000 seconds, 1,000 milliseconds. And then we play B4 and a delay. That one I want to be twice as long, so we will say 2,000 milliseconds, and then we play no tone, and hopefully that should work. Sometimes it kind of gets a bit mangled up and you have to start the simulation a couple of times. Like I said, on the actual Arduino it'll work flawlessly, but this is an emulation of the Arduino. So. Okay. Okay, so that's actually working pretty well. So I'd like you to go and have a play around, see if you can make your particular doorbell sound really interesting. Have a little fun little melody. and I will see you in the next video. Okay, so we've got our doorbell playing, but obviously a doorbell that only plays when it's switched on at the start of the day or when you install it, and then never again is not particularly helpful. You probably want to attach a button to it as well. So let's do that. So I just want to explain the wiring of these buttons a little bit. So maybe I can zoom in. So basically what happens is these two pins are actually connected to each other with a metal strip. So whether you connect to this pin or this pin makes no difference. This side will be one side, and then the wire goes through the middle here, and there's a break in the circuit which is turned into a complete circuit when you push the button, and then this will be the other side that goes out. So you want a wire coming in here and on one of these two pins, and then a wire going off on one of these two pins, and that will not be a circuit until you press the button, and then the circuit will get connected. Okay? So we could just hook this up to a light circuit, for example, where the light is here and then the button is here, all on the same circuit. So as you're holding the button, the light is on, and when you release the button, the light is off. But we're not going to connect this to the circuit of our speaker. We are going to connect it to a separate circuit, which, because it's giving us information that we're going to use in our computer program. Okay, so let's put it. A good place to actually put this is across the middle, because it fits quite nicely across like that. So let's choose another pin. I'm going to go with pin 7. Oops, I don't want black for this one because this is another one that's being controlled by the computer. So let's come out, and remember I can connect to any of these 4 slots and it will connect to this pin here because all of these are connected. And then the other side goes out to ground, and this is where I'll make that black. Okay, so this is where it becomes helpful to just have a line here that we can just connect everything to ground really easily. Okay. Now what we actually want is we want to write some code that will detect when this button is pressed, and when the button is pressed, then we activate our doorbell code. In fact, our code is not going to be when it's initially pressed, it's just going to check, is the doorbell being held down? If it is, go through the sequence of playing the doorbell, and then if it's still being held down, play it again. Okay, so I think that's the most realistic doorbell behavior we could have. So go and get yours set up like that, and then we'll dive into the code. So here we have the code that we had last time, and we need to set up pin 7. So pin mode for 7 is actually going to be detecting whether the button's pressed, so it is input. Now I'm not going to go into the details of this, but this is actually a special mode called input pull-up, which is pretty much only used for buttons. If you look in the extension course for this by Paul McWhorter, he goes into a lot of detail about how that works electronically, but we just don't have time now. So pin mode is 7 input pull-up. But it basically involves, just a quick note, they're activating the little inbuilt resistor inside the pin here that allows it to detect the button being pressed. Okay, so then what we're going to do then is we are going to go into our loop section down here, and we are going to do an if statement. So an if statement always has these open and closed brackets. So if something happens, don't type this, I'm just doing an example, and then underneath we have brackets like this. So if something, or if something, it's not if something happens, if something is true, okay, if something is true, then do the code inside here, and then you can say else, do this other thing. So we're actually looking, in this case, we're looking if button is pressed. So how do we find out if the button is being pressed? So what we do is we do a digital, it's not a digital write, we're doing a digital read on pin 7. I'll just put some spaces there to make it easy. So you can see here there's a function that checks whether there's a digital read on pin 7. If it does detect something, then this will return true. And if this returns true, then the code in here will run. Now, just to throw a spanner in the works, the way that the button is set up, and I won't go into the details again, is that it will get a digital read on 7 if it's not being pushed. So we actually have to say, if there is no read on digital 7, then the button's being pushed. And the way we do that is we put an exclamation mark at the start, which basically means if not a digital read on 7. Again, don't worry too much about it at the moment. It's just will be explained in more detail later. Okay, so what do we want to happen if there is a digital read? Well, we want all of this to happen, right? So I'm going to cut Control X, all of that stuff out. Okay, and I'm going to paste it in here. Now I can highlight all of this and press Tab. Oh no. Or Shift Tab to put it back. There we go. If you're wondering why I'm struggling with the indenting, it's because it wants to give me a 2-space indent, but on the actual Arduino software it's 4 spaces, so I'm trying to make it 4 spaces. Okay, so all of that happens. If that's not the case, if the button's not being pressed, I'm just going to put that 10 millisecond delay in again, so that we're only checking every 10 milliseconds, not millions of times a second, because that will use up way more power than we want. We're trying to be a little bit efficient here. Okay, so hopefully this works now. I'll leave that up there. Hopefully you can see. I can make that even a bit bigger just for a moment. You can copy that. Actually, I should check that it works before we actually copy everything. Let's go check. Hopefully it does. So I'll close the code and I'll hit Start Simulation. Okay, and then we'll press the button. Okay, perfect. And if I hold it, okay, so I hope you have fun making your doorbell. See if you can, make it as interesting as possible. You might like to go build it on the actual Arduino software, etc., etc., etc. That's the project finished. If you're after an interesting little extension thing, which will make your project no better at all, but will improve your knowledge, you may choose to stick around for the next minute or so, but you totally don't have to. Okay, so the thing that I just wanted to show you in the code was that I've used variables here, but if we really wanted to be very efficient, because when we're programming on microcontrollers, we probably don't want to be taking up more memory space than we have to. We might be able to get a cheaper chip for a particular device, like a doorbell, if we use less memory. So these variables here will actually get stored in the memory of the Arduino, which actually takes up memory. So if we took the 349 and just directly put it in the F4 here like that, that's actually going to take up a little bit less memory in the Arduino than if we'd used the variables. But there's actually a clever way in C of getting the best of both worlds. If you say, if you put a hash define, oops, F4 349, and we'll do the same for these. Okay, and I'll just check that that works. Okay, that has worked, thankfully. What that does is, instead of saving them as variables on the Arduino, what it does is that when you finish writing the code and you send it to the Arduino, the computer you're writing the code on has something called a compiler, which will turn all of this code into ones and zeros and then send it to the Arduino. What the compiler will do is simply take anywhere in your program that there's an F4 or a C5 and replace it with these numbers before it actually sends the code to the Arduino to be kept on the Arduino. So obviously you can't do that if F4 or B4 changes in the program sometime, because that won't work. Then there's no variable anymore. But if you have a constant like this that'll be kept the same all the time, this is a good way of optimizing.